Hello everyone, welcome to my new science called physics class. In this class, we are going to discuss distance and displacement. If we can recall very well, in our previous class, we discussed position and reference point, which are very important for us to perform any measurement in physics or science in general. So, adding to the previous knowledge, we're going to learn distance and displacement. What I mean here is that for you to understand this lesson very well, you need to watch the previous video, because we are adding on what we have taught you in that video, which is very important for measurement, as we said. So distance and displacement are almost the same thing, but there is slight difference between the two. If you can remember, we said that for you to measure anything, you need reference point, and here too we need reference point for both of these quantities in physics. For common or for layman, when we say distance, it simply means the extent between 2 points, let's say point A and point B, as we always give example. Point A and point B, we can say this is the distance between them. We can measure this distance and say something like 2 meters. This is 2 meters. That means the extent of space from A to B is 2 meters. Now, this is distance between the two. As we said in our previous class, you cannot know the distance you cannot measure this without having all these two points together. I mean, without A, you can't know the position of B, or you can't know how far is B, because you don't have reference point. For you to measure something, you need reference point. The reference point acts like something that would generally orient you in space. So this is simply distance. But let's differentiate between distance and displacement, because here they are all the same thing, because displacement from A to B is 2 meters. It's like when somebody move from this point to this point B, then the distance that this object covers is 2 meter. Okay, sorry, 2 meter, as we said earlier. Now, the displacement too is 2 meter. What is displacement? Is change in position of an object. Change of position of an object, and we use the distance between these 2 points to calculate displacement. But the difference between displacement and distance is that displacement is straight with no bend in the course of the movement of that object from the starting point to the final destination. So if something started from point A and it goes straight to point B, that one is displacement. Distance is just to measure the displacement. You can find distance if the object moves in straight line. All the distance and displacement are the same thing, as we said earlier. But when the object did not follow a straight path, then the distance will be higher than displacement. For example, when a body decided to uh, start moving from point A to B and did not follow straight line and just follow a course like this, and it reach B. This line, if you stretch it, it would reach up to, or it can reach something, it can reach more than the distance between the two. I mean, when you stretch it, it will be longer than the actual distance between these 2 points. So this in red is distance now, or the distance is higher than the displacement. So if the object moves in straight line, the displacement is 2 meter, and also the distance is 2 meter. But when the object moves in zigzag line, or did not move in straight line, then the distance will be more than 2 meter, but the displacement still remain the same thing. Displacement still remain the same thing, because what we are measuring in displacement, we are just measuring the final destination of the object, or for the initial destination, which is the starting point, and the final destination. That are this is the 2 points we are measuring. But in case of this, what do you call it? In the case of distance, we follow the course. What I say course, I mean the path of the object, where the object follows. So that is the main difference between distance and displacement. Displacement is always in the direction of the final destination. For example, if we have, let's say you have a point here and you have another point here, but in between them there is mountain. Okay, let me draw mountain. Let's say there is mountain in between these two. So this mountain blocked straight path between point A and point, let's say this is point X, let's say point X and point Y. So for you to reach point Y from point X, you cannot go straight because of the mountain. So you need to go round the mountain and reach point Y. This is distance. This in red is what? Distance. What you are calculating is distance. If you want to calculate the distance between these 2 points, you measure this or you measure the distance by following this path. Following this path would make it to be, your measurement will be based on distance. But if you still want to measure displacement is always straight. So displacement will be straight to this point, even though it's not feasible to pass through this mountain, but you must assume that you pass through the mountain so that the line will remain straight. Or you can measure this through air. You can measure this through air. So this point to this point is what? Let's just say here is 5 kilometer, while this one will be something like 5.8 kilometer. That means we have 0.8 kilometer more than the displacement. So displacement is just going straight to the point from the initial destination to the final destination with no any what do you call, deviation from the center, just going straight in straight line. This is the distance. So when we are talking displacement, when we are talking of distance, we mean any measurement that is not, it may be straight line, but it's not necessarily straight line, because it can move, it can dodge maybe something that is or something that want to cause barrier. So that is the main difference between distance and displacement, and it's very important to understand that in physics. So there is one thing that I want you to always put in mind when talking of distance and displacement, which is vector. When we say vector, that means the direction of the movement. When you are talking of displacement, let's draw our number lines, or these coordinate lines that we explained in our previous lesson. So let's say you are using this. This is y-axis, this is y-axis, this is x, this is x negative. So when you are talking of displacement, you always need to talk about the direction of the motion. For example, let's say this is south, this is south, this is north, this is west, this is east. So if you have an object here and it moves through this direction to this point, let's say you find the coordination of this point as let's say you have 5, and since everything is positive here, 5, 4. Let's say this is the coordination of this of the displacement. The object started from this point and it moves into it moved to this point. Then your displacement, if you want to define the displacement of this object, you will define the displacement of this object with the direction of the motion. What is the direction? Is southwest. Is what? Southwest. You must indicate the direction of the motion. But when talking of distance, you don't need to mention direction. So the main difference between distance and displacement is direction, because distance can decide to, when talking of distance can decide to come this way and reach this destination. It's the same destination, but in terms of distance, during the movement, the object takes different or many turns before reaching the final destination. That's the main difference. That is for distance. That's the main difference between distance and displacement. This displacement is just straight line to the point with no any change in direction. Even it is on, no matter what is here, if you are talking of displacement, it's just like straight. So let's imagine we have let's say this is water body. Okay, let's say this is water. This is a river. Let's say this is a river, and this is a mountain. This is a mountain that is blocking, and here is a village. Here too is another village. Let's say village A and village B, and there is mountain between these two villages, and there is water body here. If you are talking of distance, maybe the only way to go to point B or to village B from A is this way. This is distance. because direction here doesn't matter. You just find yourself in point B or in village B. But when it comes to displacement, you must measure it directly. So you can say in terms of displacement, the distance is not that, or the difference is not that far, or the distance between the two is not far. But in terms of the normal distance, is, or the going through the by land, let me put it this way, by land is very far. So that is it for the displacement and distance. You must know the difference between these two physical quantity. So now let's talk about the direction. When you have a quantity that requires you to when you have a quantity that requires you to give direction, like displacement, you cannot afford to forget this. Displacement, this is displacement. If you have a quantity that requires this the direction, displacement, this is vector quantity. But when you have a, let me put vector for you, it's good to start hearing about vector. This is vector. What is this? Vector. So we classify quantity as vectors. So we have, sorry, I wrote vector, vectory. So vector. Then when a quantity does not require any direction for its definition, then that quantity is called scalar. Example like distance. We have distance, and distance is what? Scalar quantity. Scalar. Okay, let me put it. Scalar. This scalar. Is it scalar or scalar? I don't know how to pronounce it very well, but I think it's scalar. So scalar quantity. That scalar quantity, we have those quantities that do not need direction for their definition, or for you to tell, or for you to define or to talk about the quantity. You don't need direction. You just need the quantity. There's a lot of quantities that are under scalar, while vector quantities are those quantities that always require direction, among them including displacement. After displacement, we have force. We have velocity. Velocity require direction, while distance does not require any direction. Then we have temperature. Temperature does not require temperature. And what again? So a lot of things. We have vector and scalar. So now you can say, oh, in physics, quantities can be classified into a fundamental or derived, or they can also be classified into vectors and scalars. So scalar quantity are those that do not require, or are those that do not require direction, while vectors always requires vectors always require direction, including example of them including displacement, force, and velocity. So now I will leave you with an exercise. The exercise is that you will Google or browse 20 quantities that are vectors and 20 quantities that are scalar. 20 vectors, 20 scalars, and write down their formula. 20 vectors, let me put it here. What you need is vectors 20 and scalar 20 and write their formula down and send it to our WhatsApp group. This is the assignment that I'm leaving you with. So before we round up, I would like to talk about time. Time is another quantity which is very important when you are talking of distance at displacement, or when you are talking of velocity. Let's talk about it a little bit. As we understand the difference between displacement and distance now, let's say we have point A. We'll always be using points. So we have point A, this point A, and this is point B. And you have two different objects. One moves in straight line to this point, but it spends 3 seconds. The other one moves from this point. Okay, the other one moved through this part, or this course from A to B, and the time is took the this is, let's say this is X and this rate is Y. The time it took the Y to reach point B is let's just say it's still 3 seconds. It's 3 seconds. But the distance now, let's define distance. Or let's see. Yeah, the distance is let's say the distance for Y is 5 kilometers. Then distance for 3 is just, okay, let me use number that will be easy for us to calculate. So the distance for Y is equal to 9. Then for X, the distance is equal to 6 kilometer. 6 kilometer. This one too is kilometer. So we have 9 kilometer for Y and 6 kilometer for X, because the actual distance now is 6 kilometer. But because object Y took very irregular, or is not going in straight line, it makes it always makes some turns when it is traveling from A to B. Then the distance, when you stretch the path, you found out that, or when you measure the whole path, you found out that the distance is 9 kilometers. Now let's calculate how fast these things move. Let's start with Y. Since we have the distance and the time spent, we can calculate velocity. Velocity, as we always say, is velocity is equal to distance over time. What is distance again? Yeah, we have distance all over time. Distance over time is equal to, what is distance here? Is 9 all over what? We are calculating for Y, so it's 9 all over 3, which is equal to 3. Good. Then for this is for Y. Then for X, we have velocity is equal to distance all over time, which is equal to 6 kilometer all over 3, which is equal to 2. What is the unit? Is meter per second. here too is meter, okay, sorry, meter per second. So object y is faster, but they end up getting into the same what, into the same they end up getting to the same in the same time. They reach point B at the same time. That means y took the longest path. That's just the interpretation. Y object y took the longest route, while object x took the shortcut. So here, the one that took the shortcut, we always define it as velocity. 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 When you hear the word velocity, just try to relate the one that took the shortcut route. So velocity is equal to distance, not distance now, because measurement of extent of space that is straight to the point, that is in straight line, is always displacement, not distance. So displacement, we have displacement all over time, all over time taken. So this is for object x. That means object x now is what? Is velocity. For object y, since it did not take the shortcut path, it followed a different path, or just not straight path. It makes a lot of turns, or it made a lot of turns before getting to point B. Then point y cannot be defined as velocity. But how do we define the speed of, or how do we define the velocity of y? The velocity of y is called speed. So instead of you to say velocity, just say speed. Speed is equal to, now it's not displacement, it's distance. Why is distance? Distance is not in straight line. So distance all over time. So distance all over time is speed, while displacement all over time is velocity. So the difference between speed and velocity is displacement and distance. Displacement always produces velocity, while distance produces time. So now, if you are calculating velocity for object y, let's say, listen, now we want to calculate the velocity of object y. It's possible to calculate velocity of object y, but you will not use this part as the part that the object follows. Why? Because if you are calculating velocity, what is your concern is just the final destination. You don't care about the path that the object followed. You care about what? The final destination. So your final destination is your concern. Now the final destination from A to B is 6 kilometers. I mean, from here to here is 6 kilometers. This is the exact distance that object X followed. So that makes it to be, for measuring speed of object Y, you just use that theory. Let me see. That theory. What? That's 6 all over 3. So the speed of these two objects will be the same, because we'll calculate. Let's calculate the distance. Let's calculate the distance of y. The velocity of y. Velocity of y is equal to 6 over 3, which is equal to what do you call it? Yes, it's equal to 2 kilometers, let's say, per second, or Okay, let's assume this 6 is in meter, so 2 meter per second. And for object y2, for object x2, the speed is x is equal to 6 over 3, because the distance is 6. We already said that the distance is 6. So don't consider path while calculating velocity. 6 over 3, which is equal to 2 meter per second 2. Now we did not look at the path, but in terms of calculating how fast is the object, then object y is faster in terms of speed, not velocity. So velocity, we calculate the resultant, what you call the resultant, the final displacement. So here is something that will help you to understand this more. When an object, let's say this is the reference point, an object started movement towards west up to 3 kilometers, then it's come back to the starting point. If you are calculating displacement is 0, why is 0 is that you are calculating where the object started and where the journey ends. Where the object started is point A, and it moves to point B, and it still come back. This going and coming back cancel the distance, because why the starting point is point A, why the final destination is still point A. That make it to be 0. So displacement here is 0. But in terms of distance, you calculate 3 kilometers for going and 3 kilometers for coming back, which will make it 6. So this is another important thing for you to know, the difference between distance and displacement. That's why sometimes people or a question can come like this. This point A, an object moved this, let's say 2 kilometers, and come back 4 kilometers. What is displacement? Then they will ask you, what is displacement? This is 2. Let's say this is west, this is east, this is east, and the object started from A, go to B, it went to B and come back to C, or come to C. So this motion here is 2. From 2 to this 2 is what? 4. So if you are calculating displacement, you just say, why is the starting point? Oh, it's point A, this point A. Then why is final destination is point C? Then the displacement is just 2 meters. But if you are calculating distance, you have 2 here, you have 2, you have 2 again, plus 2, you have another 2, then plus 2, make it what? 6. So you have 6 meters. This is very important thing to note, the difference between the distance and displacement. So there are many ways to calculate displacement using using what you call, yes, with using the same our, what do you call this thing, using our this thing. There's many ways to calculate displacement. For example, suppose let's say an object started from this 0 and move this direction to point, let's say 4, and move to this direction, let's say to okay, this is 5, let's say this is 5, and move to this direction, let's say here is 4. Then somebody will ask you, calculate the displacement now. Calculate what? The displacement, not the distance. For distance, it's just you have 5 and 4. Yes, you have 5 and 4. This is your distance. But for displacement, they always concern about straight line this way. So for you to calculate this, there's a way to do that using Pythagoras theorem that will be taught in mathematics. So how you do is that Pythagoras theorem said that if you have right angle triangle, this is right angle triangle, this is triangle, this right angle triangle. How do we know this right angle triangle? There must be this mark here. This tell you that this is 90 degree. 90 degree is the right angle. Why? When we say we have 360 degree, we have 90, we have 180, so this one is 90 degree, and 90 degree angles are called a right angle. So let's say you have 5 here, you have 4, but before writing that, let's just label this as okay, A, B and C. For you to calculate this, the formula is A square is equal to B square plus C squared. And making A to be the subject of the formula, A is already subject of the formula, because here they will give you this point, they will give you this point and they will ask you this, or they will give you B and A, they will ask you C. So let's say you have something like this, but I think the most appropriate way is to write it this way. This should be A, B and C. So the formula is that Pythagoras theorem is called Pythagoras theorem. So this theorem says that C, now this part squared is equal to A squared, that is this part squared, plus this part squared, which is B squared. This is the formula. So for you to make C to be subject of the formula, remember this is not subject of the formula. C here is not subject of the formula. For you to make C to be subject of the formula, you need to introduce a root. So you say C square is equal to A square plus B square, but now in root, so that you cancel out, sorry, let's say this is in root, this one too is in root, so that you cancel out this and this. So you have C now is equal to A squared plus B squared, everything in bracket. This is your formula to calculate C. Remember, you do the same thing if it's B that they need. So going back to this part now, you have right angle triangle. You can label it by saying here is A, here is B, here is C. And now you have your A as from 0 here to 4, because this is the distance. So you can get it by tracing it to on y-axis. You have from 0 to 4, which is automatically 4. Then you have the B, which is distance between from this point to this point to 5. So you have from 0 to 5 is your B. Then now put your formula. You have, let's take this triangle out. You have triangle like this, and this is right angle triangle. Then you put your A here, you put your B here, you put your C. Then apply your formula. Your formula says that C is equal to A squared plus B squared, everything in square root. Then what is A squared? A squared and B squared. Now A is, we said, is already 4. A is 4. Let's put, okay, let's say A is 4, B is 5. Then we have what is 4? What is A? Is 4 squared plus 5 squared plus what? 5 squared in bracket. So if you calculate this in bracket, let's see, let's put it here. C is equal to 4 squared plus 5 squared in bracket. So 4 squared, that is 4 times 4 is 16. Then plus 5 times 5 is 25. So you have this in bracket. Then 16 plus 25 is equal to, helping with calculator, you have 11, you have 30. 11 plus 30 is equal to 41, I guess so. So this root of 41 is your final answer. This is C. So how let's use calculator. So you have root of you have root of 41, which is equal to, C is equal to 6.4 approximately. This is 6.4. Now you go back 6.4 what? Let's say you are using meters. Okay, 6.4 meters. So here is 4 point what? 6.4 meters. So this how to find all this part. So now by distance, is object move from this point to this point, you can calculate the displacement. Object moves from this part to this part and stays here, you can measure the displacement. You just extract this triangle, this triangle, by using the calibration, these numbers that are on x or y axis. You will know the numbers that should be here, and these two can happen. So this in physics, but sometimes in mathematics, or most time in mathematics, let's say you have this right angle triangle. Remember, when we are drawing right angle triangle, you must not say this right angle triangle must lie this way. No, right angle triangle can lie in any orientation, like this. It can even lie something like this. So far here is boxed, is 4 corner. This part is 4 corner. That will tell you it's right angle triangle. And always remember, here is your A, here is your B, here is your C. Just the shortest, I think is the shortest one is A, while the second to the longest, I think is the B. Then the longest is C. But in physics, we sometimes put here as R, which is resultant, which we are going to discuss this in details in our upcoming lessons. So now you want to practice, you have exercise of giving us 20 vectors or vector quantity, and what, 20, we have 20 vectors quantity and 20 scalar quantities. Then here practice this solving rectangle. Remember, our formula is talking about C square is equal to A square plus B square, but you can change this by taking this to this side and taking this to the other side, or let's just make B squared to be subject to formula. You just say C square minus A square is equal to B square. How do we get that? We just took A to the other side of the equation. Then it will give us this B as subject to formula. This can be changed to B square is equal to C square minus A square. That's all you need. So you can make any of these three to be the subject of the formula. But remember, at this level, you did not make the B to be the subject of the formula. For you to make B to be the subject of the formula, you must remove this what do you call it, this square, by putting everything in square root. Everything in square root, then you have your B. If you calculate this, you will get your answer. So please practice coordination using these vertical and horizontal lines, and trace something in the middle or somewhere. State the direction. State the direction, because now this is 6.4 meters, but even I said 6.4 meters, this is not correct until I said in southwest direction. In southwest direction, that southwest direction must be there for it to qualify it to be a displacement. If not, you end up having distance. So displacement always have direction. What is the direction of the displacement? You must state it. So this is what I will leave you with. Thank you very much for your time. Hope you understand this lesson very well. If you do so, please like, comment, share, and also subscribe and open notification button so that we will get notified when we release our next lesson. This is very important lesson. If you like or you want to understand it more, please repeat the video again so that you will grab all the information that is there for you. And if you have any question, feel free to put it in the comment section or message us on WhatsApp using our regular phone number, which is 081 28 14 18 16, and message us through WhatsApp, and you can still use this number to get into our science classes. Thank you. See you in our next lesson. My name is Science School. We are always proud of you for your usual support and everything. Thank you.